Friends, welcome back my YouTube channel MS Maths. In this video, we're going to discuss about a definition of the function related to the measure theory. So the definition is basically let fn be a real valued function, then it can be written as a positive part of the function and a negative part of the function simultaneously. The positive part of the function will define or will denoted by the f plus, and negative part is basically f minus. So what is the definition of the positive part is basically the maximum of f and 0. That is basically if fx is greater than 0 or equal to 0, then it is f, and if it is less than 0, then it is 0. It is the definition of the positive part. And the negative part, similarly, the minimum of f and 0. It means if it is equals to and greater than 0, functional value is equals to and greater than 0, then it is 0, or it is less than 0, then it is minus of f. So this is the basically the definition. So positive and negative part of the real valued function are always non-negative. Okay, so we'll prove that we can write a function in terms of just yes, in terms of f of f of plus minus. Yeah, it is minus. I think it is not plus, it is minus. It is typing error. Yeah, so we can write a function in terms of f plus minus f of f minus. So how can we write it? Just what is the proof for this? So the proof for this is basically let my function f of x is greater than equals to 0, then what will happen? It means f plus is equals to f and f minus will be 0. If it is function greater than 0, then you can see here for the negative part, okay, 1 second, it is also the typing error, f minus will be there. Okay, now f of 0 will f minus of 0 will be 0. Yeah, f of minus will be 0 because of that f is greater than equals to 0. Okay, now we'll have now where now wait now we have f plus minus of f minus is what? F minus, or basically f plus minus 0. Yes, if we wish to prove it is my function f, then f plus minus f minus is equals to f plus minus of 0, and that is what equals to f. It means my f plus is equals to f, it is whole. So that we can say that f plus is equals to f. And again, just simple results are there. If my f of x is less than 0, it means that f plus will be 0 and f minus is equals to complete f. It means f plus minus f minus is equals to f. Then we can just prove that f plus minus, what is f minus is what? F minus is f. Okay, yeah, it is f plus, and f plus f plus is equals to f, then f is equals to f is here. Okay, so this result will holds, and same thing will here. So f plus minus, okay, yeah, here f plus will be 0. Okay, f minus is equals to f, then f plus will be 0, it is minus of f. Okay, it is minus of f. F minus is basically, or basically minus of f minus is equals to f. Then it means that it is also f is equals to f, and it is also whole. So that we can write so this will also be the whole. So we can write f of x is nothing but f of plus of x minus f of minus of x. So these both result will hold, and we can just conclude this. Now the next result is basically the mod of f is what? The mod of f is equals to f plus plus f minus. It means how can we verify it? So we'll take just two case. So what is the case number one? Case number one is just f of x is greater than equals to 0. It means f plus is equals to f, and f minus is equals to 0. It means f plus minus f minus is equals to, oh sorry, yeah, it is plus. So it is 0, then what? F plus is equals to f. And second one is the case 2 is what? F of x less than 0. It means f of plus is equals to 0 and f minus is equals to f, or basically yeah, it is f. So that f of plus plus f of minus is equals to minus of f. That we can conclude that mod of f is what? Mod of f is f plus plus f minus. So that we can conclude this result here. Okay, mod of f is equals to f plus plus f minus. This is the result that we want to prove here. So it means we can define a mod function in such that the mod function is what? Whenever f of x greater than equals to 0, then it is f, and whenever f of x less than 0, then it is minus of f. Okay, hence prove that f plus plus f minus is what? Hence prove. Now, next theorem is basically a function is measurable if and only if its positive and negative part are measurable. So we have to prove that we have to prove that the result in terms of if and only if, it means we'll prove that there's sufficient condition and necessary condition. So conversely, we all, like also we have to show that conversely will be true. So let f is a measurable function and f plus and f minus be the two part of the function. Okay, then to show that what we want to show that f plus and f minus is measurable. Now, since 0 is measurable and f plus is equals to the maximum of f and 0, and what is f minus is the minimum of f and 0. Now, here f and 0 both are measurable, then the maximum, both are measurable, and earlier we have proved that the maximum and minimum values of two measurable function is again measurable. It means f plus and f minus both are measurable. Okay, so that's the concept. Next, conversely, if f plus and f minus both are measurable, then f is measurable. Okay, conversely, if f plus and f minus both are measurable, then f is equals to f plus minus f minus, then the difference of two measurable function is again a measurable function, so that f is equals to f of plus minus f of minus is also measurable. So this is the definition. If these both are measurable, then addition, multiplication, and difference all are the measurable function. Okay, so this is the result that we have earlier proved. We can use just that result here. Okay, now next here, related to the positive and negative part. If f is a measurable function, then mod of f is also be measurable, but converse not. It means f is a measurable function, then mod f is measurable. Then mod f is measurable, then f need not be measurable. So we have to show a contradictory example for the converse. Okay. Now proof. As f is a measurable function and f plus and f minus is also be a measurable functions, so that the mod f is defined as f plus plus f minus, then the sum of two measurable function is also measurable, so that the mod of f is a measurable function. Now we want to prove or we want to disprove that if f plus and f minus, or sorry, mod f is measurable, then f is not measurable. Okay, so we'll just show a contradictory example. But converse of above result is not true, because let E be a non-measurable set. We have just taken example of non-measurable set, and we will prove that f mod f is measurable on this set. It means let f is what? Chi of E x minus 1 by 2. It means it is a characteristic. So the characteristic of E not measurable, because the characteristic of function A is measurable if and only if A is measurable. It means the set is measurable, then the characteristic of set will be measurable. If set is not measurable, non-measurable, then characteristic will also be the non-measurable. Okay. What is the mod of this function? It is what? The mod of chi of E of x minus 1 by 2. Okay. How can we define the mod function? We can just define if x will, sorry, we can just define this chi as x. If x belonging from E, then it will be 1 minus 1 by 2. What is this? 0 minus 1 by 2 when x does not belong from this. So it is basically 1 by 2 and 1 by 2. If x belonging from E or x does not belonging from E, it means what? The mod of f is 1 by 2, which is a constant function. Which is a constant function. If it is a constant function, then it is a measurable function. Then mod f is a measurable function. But f is equals to chi of E minus 1 by 2 is not measurable. This is not measurable, but mod of f is measurable. So this is just a contradiction. So it is a contradiction. Then the converse of theorem is not true. So this is the theorem. That is basically potent theorem and very easy theorem. Thanks for watching my video. Keep watching MX Maths. For more videos, you can subscribe my channel. Thank you. Bye bye.